Alrighty, we're here in chapter 1.4. I would say one of the most important sections in this chapter and of the year. This is a skill that we're going to use not only the rest of this year, but you're going to use throughout your high school and college career. And it's a skill. It's unit conversions. It's very important. Now, when we're converting units within science, we use a special method called dimensional analysis. All right, so this is an organized method to convert our units. Now, why is this important? Well, because in chemistry, physics, engineering, medicine, carpentry, welding, any of these fields, a lot of times you're going to measure units that you can't use in, let's say, your math or your calculations. You're going to have to convert them. So this is an organized method to do that. It communicates our process to other scientists and to ourselves that we can follow to make sure that we don't mess up. Or if we do mess up, catch ourselves. So how do we do this? Well, we're about to find out. So, I always say the best way to learn is to learn by doing. So dimensional analysis for me is a 5-step process with a few things that we have to keep in mind. And if we do, any conversion that we do from now on is going to be a piece of cake. So here I have an example problem. We're going to start off simple. Simple 1-step dimensional analysis question. I want to calculate how many minutes are in 3.61 hours. Now, I know you're probably thinking to yourself, this is pretty easy. I already know how to do this. Yes, I know that. But if we learn it simple, we will grow on these basics into more complex problems. So the first problem I would say is write down what the problem gives you. It starts organizing your thoughts. Now, the way I teach dimensional analysis is I use the T-chart method. So our second step is to draw a T-chart around that given that I just wrote down. And I place it in the upper left-hand corner of that T-chart. So my third step, I should say, is we're going to find a relationship between the unit I'm in and the unit I want to go to. Now, right now, we have a direct relationship. We know that 1 hour is equal to 60 minutes. Now, later in this section, we're going to see that it's not going to be that simple all the time. Sometimes we're going to need 1, 2, 3, 5 different conversion factors to get from point A to point B. And that's okay, as long as we're following this T-chart method and we're finding the relationships that get us there. So what do I do with this conversion factor? Well, I'm going to put it into my T-chart. I'm going to place it into my T-chart on that right-hand side. And how do I know which numbers go where? Well, it's a very simple principle that if you remember now, it will be the same throughout this entire section and the rest of the year. Like units will always be diagonal from each other. If you can remember that, you will be well off. So here we see that I had 1 hour and 60 minutes. Where do I put the 1 hour? Where do I put the 60 minutes? Well, look at that given. I see that given's up in the top left-hand corner. Well, I'm going to put 1 hour diagonally from it so that they will eventually cancel. So I put 1 hour there, and well, it has to take 60 with it, so 60 is going to go above it. For all of you super awesome math people, you see that we're setting up a proportion or a fraction, and that's okay too. So here we go. Step 5 is pretty simple too. So in step 5, this is where we're going to do our canceling of units and our math. So in your calculator, it's very simple. You're just going to multiply the numbers that are on top and then divide it by the numbers on the bottom. So here I do 3.61 times 60. I get 216. Then I divide it by the number on the bottom, which is 1 hour. And as we know, anything divided by 1 is itself. So here I see that it's 216.6 minutes. Now how do I know it's minutes? Well, because my hours canceled out. I have to make sure that my units are diagonal from each other. If they're diagonal, they will always cancel out. And whatever is not canceled out, whatever I don't have another unit of, it will be that unit. That's the unit that I'll be in. So let's try it. Let's have you try it here. So on your own, I'm going to pause here for a few seconds. So pause the video, and I want you to try to solve this on your own. Then when you're done and have an answer, unpause the video and I'll go through the solution with you. But what I'm asking you here is how many centimeters are in 4.2 inches? And this time I've given you a conversion factor. I've already done step 3 for you. You're welcome. So, try it out. All right, I'm going to solve this here for you, or with you, I should say. So, first step, I write down what's given, 4.2 inches. That's where I got out of the problem. Then I'm gonna make my T-chart. Boom, T-chart. Now I have to put my conversion factor in. My third step was to make my conversion factor, but it was already given to me. So I can kind of go over that step. So now I have to figure out, okay, where does that 1 inch go? Where does that 2.5 centimeters go? And if you recall, our trick to this is our like units go diagonally from each other. If they go diagonally, they will cancel out. So I'm going to put that 1 inch in the bottom right hand corner, and 2.54 is going to come with it. It's going to go above it. Now doing my math, multiply across, divide by the bottom, and making sure that my inches cancel out diagonally, I find my answer to be 10.67 centimeters. So let's try another one. Maybe you didn't get that one. Let's try again. Learn from your mistakes. See if you can get this one. How many seconds are in 36 minutes? Now this time I didn't give you a conversion factor, so you're going to have to figure it out on your own. And I want you to make sure you write it down somewhere. Alright. Alright. Hopefully you solved it by now. And we're going to solve it together. So, write down what's given. 36 minutes. And I'm going to draw my T. And now I have to think of my conversion factor. So hopefully you know that there are 60 seconds in 1 minute. So I'm going to place 1 minute in the bottom right, 60 seconds on the top right. Multiply the top, divide by the bottom, making sure that minutes cancel out diagonally, and I'll be left with 2,160 seconds. Alright, so hopefully you've been doing really well. Because now we're going to step it up a notch. We're going to do a multi-step dimensional analysis question. This means that we're going to use more than one of our conversion factors to get to our endpoint. So here my question is, how many minutes are in 2 weeks? So you're going to have to think of all the conversion factors that get you from minutes to weeks. So see if you can solve this one, but we're going to solve together here now. So it starts off the same way. I write down what's given, and I draw my T. Now, this third step is to figure out all of our conversion factors for this section, or for this problem. So I need to get from minutes, or from weeks to minutes. All right, it might not be direct, but I'm going to think to myself, all right, I know that 1 week has 7 days, so 1 week equals 7 days. And I know that 1 day equals 24 hours. And I know 1 hour equals 60 minutes. So see how I wrote down, I thought of all these conversion factors in my head. And now I just fill them into my T-chart. So I'm going to start with weeks. What did I know about weeks? Well, I knew that 1 week had 7 days in it. And again, notice that weeks are diagonal from one another. But I'm not done. I need to get farther. I'm in days. I need to get to minutes. So just add another T. It works the same. Just keep building these conversion factors. Just make sure that your units cancel diagonally. So add another T. When you add another t, think of your next conversion factor. All right, I'm in days. What's my next step to minutes? I probably need to get in hours. So I know that one day has 24 hours. And keep building it. I know that hours has 60 minutes in it. All right, now I'm in minutes. So this works the same way mathematically, except I'm going to multiply everything on top together, get a number, then multiply everything on the bottom and get a number. Divide those two numbers and you'll get your answer. In this case, it will be 20,160 minutes. Now notice that my units did in fact cancel diagonally. My weeks canceled out, my days canceled out, and my hours canceled out, leaving me in minutes. So let's try another one on your own. So here I give you 1,849 yards, and I want you to convert it into miles. And I gave you some helpful hints here. I gave you some conversion factors to help you do that. So pause the video and try it out on your own. Unpause and I'll give you the answer. Alright, so hopefully you have an answer by now. And we're going to go through this. So, starts off the same way. Put in what it gives you. 1,849 yards. Put my t in. Now looking up the conversion factors that I gave you, we see that 1 yard is equal to 3 feet. So I'm going to fill in that conversion factor into my t chart, making sure that yards are diagonal from each other. So yards is going to go on that bottom there, 3 feet above it. Now I'm not done. I need to get to miles. So that's where my second conversion will come in. So I'm going to add another t, and I'm going to put in my next conversion factor. So in this case, I'm going to put feet diagonally from the other, that 3 feet. I'm going to put 5,280 feet diagonally from it. So now this is the first time that we've seen like a real actual number that wasn't 1 in the bottom, and that's okay. And again, so when you do your math, you're going to multiply across the top, you're going to multiply across the bottom, you're going to get two numbers, you're going to divide those two numbers, and you're going to divide them. Okay? And again, make sure that we canceled the yards, we canceled the feet, I'm left in miles, and you should have gotten 1.05 miles. So hopefully you got these multi-step ones, because we're about to kick it up one more notch. So here's our next step. This is going to be multi-dimensional, multi-step dimensional analysis. So if we look here, I have a derived unit. I have kilometers per hour, and I need to convert it to meters per second. So now I have two units to worry about converting to, which if we build our conversion units correctly, we shouldn't have a problem. So this is kicking it up a notch. So starts off the same way, except this time, now that we have that more complicated unit, kilometers per hour, we have to fill in a little bit more in our T chart. So if we notice here, I placed 50 kilometers in the top and then hours underneath it. So if you look at our units, kilometers per hour, there's that line in between them. Just like there's a line in between them on my T chart. So it's going to work the same way, except for right now, I'm going to ignore hours. So ignore hours for right now. We're going to focus on getting kilometers into meters. Because if we look there, kilometers per hour to meters per second. I need to get kilometers to meters. So how do I do that? Well, if we look there, I have a conversion factor. So I'm going to put in my kilometers in the bottom and my meters in top because my like units need to be diagonal. And if I did this normally, we would notice that yes, I would be in fact in meters, which I was trying to get to. So I can stop worrying about my kilometers. Now I'm going to forget all of that, what I've done up there. I'm going to ignore it. I'm going to look at the hours. I'm going to throw another T in there, and I'm going to ignore all that other stuff, and I'm going to go back to hours, okay, and convert hours into seconds. So we know those conversion factors. Now the trick here is to still make sure that my units are diagonal. Even though they're farther apart, as long as they're diagonal, they will cancel out. So we look here, hours So I know 1 hour is equal to 60 minutes. So 1 hour is actually, this time I'm going to go in the top, that top quadrant there, and 60 underneath it. So that's a little bit of change, but notice they're still diagonal from each other. But I'm not in seconds yet. I have to tack on another t. And again, I got to put in my next conversion unit, which is 1 minute to 60 seconds. Again, notice minutes are diagonal from one another. And double check yourself. Kilometers cancel diagonally. I'm left with meters. Hours cancels diagonally. Minutes cancels diagonally. And I'm left with seconds. And we notice that I have meters on top and seconds on the bottom, just like my unit, meters per second. The math works the same way. Multiply everything on top, get a number. In this case, it's going to be, looks like 50,000. And then we divide everything, or we multiply everything on the bottom and get a number. And we're going to divide those two numbers, that 50,000 by I think 3,600. And we should get 13.89 meters per second. So that was a more extreme case, so that multi-dimensional, multi-step unit analysis. So if you're feeling up to it, I have a challenge question on this next slide. See if you can do it. So here it's a little more complex, a lot more conversion factors to deal with, but as long as you keep to our basics that we've learned in this video, you should be fine. So I need to convert density of 0.58 grams per milliliter to pounds per gallon. So see if you can figure this out on your own. I'm going to pause for a second and let you do it, and then I'll come back. And we're back. So hopefully you got an answer. So we're going to write what's given, and again, since this is a derived unit, it's very complex. I have grams over milliliters. I'm going to put grams over milliliters in my t-chart. I'm going to forget about my milliliters first and focus in on those grams. I'm going to get those grams into pounds because that's what the problem asked me to do. If we notice there, grams per milliliter to pounds per gallon, grams to pounds. So looking at my conversion factors, I know that 1,000 grams equals 1 kilogram. So I'm going to put 1,000 in the bottom and 1 kilogram up top. Then I'm going to tack on another t because I'm not done yet. I need to get to pounds. But I see I'm also given a conversion factor of 1 kilogram equals 2.2 pounds. So I'm going to put that conversion factor in there, making sure kilograms are diagonal from one another. We notice grams cancels, kilograms cancels, leaves us with pounds. That's what we want. So now we're done with the grams part. Now we're going to forget all we did, throw another t in, all right? And now we're going to convert the bottom unit, making sure that units are going to be diagonal. So I need to get milliliters into gallons. So we notice that 1,000 milliliters is equal to 1 liter. Notice how, see how far they're apart, but they're still diagonal from one another. The milliliters will cancel out. All right, I'm not done yet. I need to get liters into quarts. And if I look at my conversion factors, 1 liter is equal to 1.057 quarts. Liters are diagonal from one another. One more step. We got to get quarts into gallons. And I know that there's 4 quarts in a gallon. And again, double check yourself. Go through. Grams should cancel. Kilograms should cancel diagonally. I'm left with pounds. That's good. That's what I want. Then my milliliters cancel. Then my liters cancel. And then my quarts cancel, leaving me with gallons. So I have pounds over gallons. Now I have to do the fancy mathematical part. Multiply all those numbers on the top. Multiply all of them. Get one number. Multiply all those numbers on the bottom. Get a number. Take those two numbers and divide them. And you should get a 4.8 pounds per gallon. So hopefully you know how to do this whole dimensional analysis process. If you're still having problems, come see me. All right. Enjoy.